Hi everyone, thank you so much for clicking onto the video. Today we're going to be looking at practical skills, so the techniques and procedures used for the preparation and purification of organic solids, involving use of a range of techniques including organic preparation, use of quick fit apparatus and distillation and heating under reflux, and the purification of an organic solid by filtration under reduced pressure, recrystallization and measurement of melting points. We're then going to look at a required practical, which is synthesizing an organic solid. So now I'm going to start talking about how to purify an organic solid. And so there are two steps in purifying an organic solid. We have the first step, which is filtration under reduced pressure, and then we have recrystallization. And we can then determine the compound's melting point to test how pure it is. So if it's pure, the melting point will be sharp, and it'll be also equal to the data book value for the pure compound. So we're firstly going to look at filtration. So we can separate out a solid product from a solvent or a liquid reaction mixture by using filtration under reduced pressure. So the overall method is that firstly you connect one end of the pressure tubing to a vacuum outlet. So we normally use a tap in a classroom setting, and we attach the other end to the Buchner flask. We then fit the Buchner funnel to the Buchner flask, ensuring that there's a good tight fit. And this is usually obtained using a rubber bung, which we can see here. So this shaded bit here is the bit of rubber which seals any gaps between the funnel and the flask. We then switch on the vacuum pump, so the tap that the filter pump is attached to, and then check for good suction by placing your hand across the top of the funnel. And on the funnel, there are little holes. So when you put your hand across the top of the funnel, you should be able to feel some suction coming from the holes. And we then place a piece of filter paper inside the Buchner funnel and wet it with the same solvent used in preparing the solid. And the paper should be sucked down against the holes in the funnel. We then slowly pour the reaction mixture from a beaker into the center of the filter paper. So we have to make sure that it doesn't run over the sides of the filter paper, because then it won't be filtered. And then we rinse out the beaker with the solvent so that all of the solid crystals collect in the Buchner funnel. We then rinse the crystals in the funnel with more solvent and then leave them under suction for a few minutes so that the crystals start to dry. So on the right, we have a diagram of this. We have the tubing to the vacuum pump. So this would be attached to a tap, and the other end is attached to this Buchner flask. We then have the Buchner funnel securely attached onto this Buchner flask, so no air can escape. And so what we do is we're pumping all the air out. And so when you put the filter paper inside the Buchner funnel, it should be sucked down right to the bottom of the funnel where all the holes are. And so this is how we can separate our solid product from the solvent or the liquid reaction mix. And so we collect all of the purified product on top of the filter paper. Now we're going to have a look at recrystallization. So after the solid product is obtained after filtration, it will contain impurities. So we call it a crude product. And we use recrystallization to remove all of these impurities. So the overall method we have is that firstly we pour a quantity of the chosen solvent into a conical flask. And if the solvent is flammable, we warm this solvent over a water bath. But if it's just water, which isn't flammable, then we'll warm it with a Bunsen. We then tip the impure sample into a beaker and slowly add this solvent, which is now warm, to this impure sample until it dissolves. And a really important thing to know is that we only add the minimum volume of solvent required to dissolve all of the solid. We then filter this solution hot using a Buchner funnel and pump that we've just seen. And the Buchner funnel makes sure that the solution doesn't cool too much whilst it's being filtered. And we then throw away the residue, because what we want is actually the filtrate, which is the liquid which we obtain in the Buchner flask. We then allow this solution to cool slowly, and if no crystals appear, we'll stir it vigorously for a few minutes, but crystals should appear without stirring. We could also try scratching some of the glass as well, which will trigger some crystals forming. We then filter the crystals cold, again using Buchner funnel, so under reduced pressure, and we will then be able to obtain this dry crystalline solid. We then wash this residue with a small amount of cold solvent and dry the product on a watch glass at room temperature or in an oven. And an important note is that we can take the mass of this product then warm it, and then reweigh it. And when this mass becomes constant, we'll know that it's dry because that means all of the water will have gone from it. And so we need to know a few of these important conditions and why we have them. So the first is that we have to dissolve the crude product in a minimum volume of hot solvent. And the reason why the solvent has to be hot is because it ensures that all the product dissolves and the insoluble impurities are not dissolved. And so they stay in the Buchner funnel and we can remove it. And so this is also a key thing to note when we want to choose different solvents to use. We need to find a solvent where we can dissolve the product. So the product can dissolve in this hot solvent, but insoluble impurities won't. And we have to use a minimum amount of the solvent because this ensures saturated solution. And so all of the product will precipitate out when cooled. So what that means is that all of it will form crystals. And the second condition is filtering it hot using the Buchner funnel. And we do this because it removes all of the insoluble impurities as we want the filtrate. So the thing in the Buchner flask, so the liquid, as this contains the dissolved product. And this will also contain the soluble impurities. And so this is why we filter it cold after, because this removes all of the soluble impurities, which were in this filtrate. And then we can obtain the product in the filter funnel. So when we filter it hot, the thing that we want is inside the Buchner flask. So it's the liquid. And this liquid will have what we want in it, but also some soluble impurities. But then after filtering it cold, we then have the solid because it's all formed crystals at the top. So the solid will be what we're after, the pure product, and the soluble impurities will then be in the filter flask, and that will be the filtrate. So that's how we remove the soluble impurities. So after we've gone through recrystallization and obtained our product, we can then look at the melting point of this product. So we can use melting points to determine whether a solid compound is pure. And so a pure organic substance will usually have a very sharp melting range. And this will be over 1 or 2 degrees. And melting range is the difference between the temperature at which the sample starts to melt and the temperature at which melting is complete. So because the sample we obtain is white, we can see when it's fully melted because it'll turn colourless. And an impure sample will melt over a wide range of temperatures, and its melting point will be a lot lower than a pure sample. So the pure sample is the one we find in a data book. And we can determine the melting point by using an electrically heated melting point apparatus, an oil bath, or a field tube. So the first thing we need to do is prepare the sample. So we take a capillary tube or a melting point tube, and we hold one end of the capillary tube in the hot flame of a Bunsen burner and rotate the tube until the end is sealed. We then allow this capillary tube to cool, and then we can fill it with our crystals that we've obtained from recrystallization. And we do this by pushing the open end of the capillary into the solid sample to force some of the solid into the tube. And then we can use one of the 2 methods below to find the melting point. So firstly, looking at using electrically heated melting point apparatus, the first thing we do is place the capillary tube, which has our sample into the sample hole, and a 0 to 300 degrees thermometer into the thermometer hole of the melting point apparatus. So this is what we can see on the diagram on the left. So we have our thermometer sticking out. And using the rapid heating setting, we then start to heat up the sample whilst observing the sample through the magnifying window. So the diagram on the right is our magnifying window. So we can see that. This bit here is white. And so this is our product. And this section here is beginning to melt because it's colourless. And so we can see our melting range because we can see when it starts to turn colourless and when the whole thing is colourless. So once the solid is seen to melt, we then record this melting point and allow the melting point apparatus to cool. And we then prepare a second sample in a new capillary tube and place in the melting point apparatus. And again, we do the same thing with heating it up and recording its melting point. And this time, as the melting point is approached, we set the apparatus to low and raise the temperature slowly whilst observing the sample. And so this is how we can get a more accurate determination of the melting point. The second thing we can do is use an oil bath or a field tube. So we set up the field tube or oil bath like the diagram on the right. So this is a field tube. And we attach the capillary tube containing the sample to a thermometer using a rubber band. And we insert this thermometer through a hole in the cork if using a field tube, or clamp it to the thermometer if using an oil bath. And a really important thing is that the end of the thermometer and the end of the capillary tube should be dipped into the oil. And this is because the oil is what we're heating. And so in order for us to actually heat up the capillary tube properly, it needs to be in the oil. And then using a micro burner, we then slowly heat the side arm of the field tube or the oil bath whilst observing the solid. And when the solid starts to melt, so again when it starts to turn colourless, we remove the heat and record the temperature at which all of the solid has melted. And it's really important to heat the oil slowly when approaching the melting point. And then we repeat the melting point determination a second time to ensure that we have an accurate value.